So now we have a circuit here where we control the brightness of the LED with the trim pot here. But we're using an NPN bipolar junction transistor, the 2N3904, as a current source. We have an adjustable signal voltage though, but in any case we have a 220 ohm resistor to the emitter of the bipolar junction transistor. Base, we got this 10K resistor because we don't want current flowing too much if we go to the positive supply. But in any case, the LED is on the collector side over there. Kind of bent the wires out of the way there. So in any case, we have the 220 ohm resistor. If we set about 2.8 volts, just to keep the math easy, right there, let's say that's 2.8 volts, we should have about 2.2 volts across the 220 ohm resistor, giving about 10 milliamps of current. Now that 10 milliamps of current goes through the LED and the transistor as well. So now here's the schematic diagram for this circuit. We'll zoom in. So now we have an NPN bipolar junction transistor. There's a resistance on the emitter side. That makes it a current source. The voltage you set to base is going to transfer, but you're going to lose 0.6 volts. But that voltage is going to go across the resistor. Transistors are going to conduct as needed to keep that voltage there. And we also got an LED on the collector. So it's going to pass whatever current needs to pass through to get that done. So if we go directly to positive supply with that trim pot to the base, that would build up across the resistor. We don't want that, and because that would cut away power from the LED. So we got a 10K resistor there, so the voltage can transfer over. But let's say we set the base voltage to 2.8 volts. That'll get about 2.2 volts approximately across the 220 ohm resistor, and the transistor will conduct to do that. So you'll have 10 milliamps of current flowing, which will also go through the LED. So now, I said with this circuit, if I set 2.2 volts across the current setting resistor there, it's a 220 ohm resistor. That means we'll get about 10 milliamps of current flowing through it, the transistor, and the LED. So I had to turn the trim pot, I guess, to about 2.8 volts. Looks like about 2.9 volts, but that does make sense. So now I'm going to pluck this jumper and put it somewhere where it's out of the way. I'm going to pluck that jumper, and then I'm going to, we got to put the current through the meter to measure current. So I'm going to set it to measure milliamps of current, and we're going to put it in series with the LED, the transistor, and the current setting resistor. And there you can see we have about 10 milliamps of current. So again, this was all approximate, but I was pretty accurate there on how much current we would get flowing through here. So now we're going to shoot for about 5 milliamps of current through this circuit here. We're going to set the voltage across the current setting resistor. It's a 220 ohm resistor. We want about 1.1 volts for about 5 milliamps of current through the red LED and so forth. Now we have to measure current through the circuit, and therefore we're going to have to remove it. Now I'm going to put the black probe to where the LED is before I set this to measure current, and then I'm going to go to milliamps. We don't really want to have current flowing while I'm changing the settings. Now we can get the current flowing by completing the circuit. I stuck that up one spot too high, that black one. So yeah, there we go. We had a little bit more than 1.1 volts and across the 220 ohm resistor, so we have a little more than 5 milliamps of current. And make sure you turn the meter off when you're done. Good to get it off of measuring current.